Hey, everybody. Welcome to Environmental Coffee House. Welcome to our Sunday show. And I'm so pleased to be joined with Jim Massa tonight. We're going to take a deep dive again into the oceans in a little bit of a different way than last week. And we're also going to be talking about the great dying. So let me tell you about the two great articles that we're going to be talking about tonight with a video in between. First up, an article that just came out this week from the New York Times, and it's talking about in the Atlantic Ocean, subtle shifts hint at dramatic dangers. The warming atmosphere is causing an arm of the powerful Gulf Stream to weaken, some scientists fear. And Sandy's going to play a little video, and then we'll cover an article from CBS News. The Great Dying, Earth's largest ever mass extinction, is a warning for humanity. And before we get started with all of this, Jim is going to give us an overview of the Gulf Stream and all its particulars. So thanks, Jim. I'm so happy to be doing this with you tonight.
Likewise. Thank you, Jen. Always good to join you in our discussions here. Well, Gulf Stream is the most studied current in all of oceanography history. It actually forms, it splits as it gets past like the Labrador area. It splits into a branch that goes towards what we call the Jin Sea, the Greenland, Icelandic, Norwegian Sea. Another branch splits off that heads down towards off the western coast of Africa, which actually helps define what's called the North Atlantic gyre. The Gulf Stream itself is actually driven by wind stress. You got the westerlies, you got the trade winds. Winds below it push on the water surface, and it creates a stress. And what a lot of people may not realize is that the effects of the wind can be felt down several hundred meters, down to what we call the Ekman layer. We won't get too wonky here, but what the interesting thing about the Gulf Stream is that, and this is based on the work of Harald Sverdrup, who we honor with the Sverdrup. The Sverdrup unit is a unit used in oceanography that describes flow and of currents. One Sverdrup is basically 1 million cubic meters of water flowing past a point per second. That's a lot of water. So imagine a chunk of water that's a kilometer in width, a kilometer in length, a meter thick, and that flows past a point per second. That is an extreme amount of water. And it's called the Western intensification. When you look at oceanic gyres, the western flow, western side of the gyre, tends to be faster flowing. And also the currents on the western side of the gyre are narrower. They're also deeper and they flow much faster, as I just mentioned. So Sverdrup did some preliminary research, and he was working in the first half of the 20th century. And he was trying to develop equations that would balance what's called geostrophic flow, wind stress, and vorticity. And here's the starting point. Then along came a guy named Henry Stommel. And Henry Stommel is like the guy. He was the one that was able to come up with the equations that describe the motion of the Gulf Stream. And that was where he basically discovered the Western intensification. So if you look at the North Atlantic gyre, the western side of the gyre has this fast flow. The eastern side off Africa, the current gets very wide and it slows down considerably. So here's some values where I got some notes down here. Let's see, where the flow comes out of the Florida Strait, it's 30 Sverdrups. By the time the Gulf Stream gets up past Newfoundland, it has sped up to 150 Sverdrups. So that's 150 times 10 to the 6 cubic meters of water per second flowing past a point. Surprisingly, the Gulf Stream is not the fastest current on the planet. The Antarctic Circumpolar is. That's another episode. So so it really speeds up, and part of the speeding up is due to this western intensification because of vorticity considerations. So another thing about the Gulf Stream is that it is not a ribbon. You can see in the little graphic there, you see all these little eddies and various aspects that pinch off. Those are called mesoscale eddies. They're on the order of tens to hundreds of kilometers in diameter. And depending where they pinch off, they'll either rotate in a clockwise or counterclockwise manner. But it's all this pinching off is doing what we call eddy diffusivity, which is basically a fancy way of saying mixing. But it's doing what? It's mixing salt, heat, nutrients, etc. That kind of stuff there. Now, the Gulf Stream has a temperature range of anywhere from 7 degrees to 22 degrees C. Obviously, it's going to be warmer when it's coming out of like the Gulf of Mexico area, and it's going to cool down as it approaches the Jin Sea. Even though it has cooled down to say around 7, 8 C, it's still warmer than the surrounding waters in the Jin Sea. So heat is still given off, which keeps Scandinavia and the UK warmer than it should be for those latitudes. And of course, as it's giving off its heat, it's very salty. It now becomes cold and very dense, and it sinks. And this is how we get the start of the the deep water formation, the Atlantic meridional overturn circulation, and what we colloquially call the start of the conveyor belt. The salinity of the Gulf Stream is about 36.4 parts per thousand, and that's an average, over the whole length of it. On average, the Gulf Stream it's about approximately 100 kilometers in width. The depth will range from say 800 down to 1,500 meters. It's about 6,400 kilometers in length, and it's a very powerful force. So you have other things like evaporative cooling as it proceeds up north and so on. But I think the first part of the Gulf Stream is definitely wind driven, and by the time you get to the northern branches towards what's called the North Atlantic Drift, then it becomes more of a thermohaline driven circulation. And I think I'll just leave it there. I hope that sets us up for our discussion.
Yeah, and there's a couple of little known facts about the Gulf Stream that I'd like to just bring up. Did you know that the Gulf Stream was first noticed by Ponce de Leon in 1515, Portuguese explorer, and he was trying to sail the other way from the Gulf Stream, and he kept getting put back. Even though the wind was trying to take him this way, he kept getting pushed back, and he's like, what the heck? And it was actually first mapped by Benjamin Franklin in the late 1700s on one of his journeys to Britain. So yeah, it's kind of interesting, fun facts to know and tell about the Gulf Stream. But thanks very much for that introduction with all those facts about Gulf Stream. It also affects the weather up in Scandinavia and in England and Ireland and all those kind of northern countries. They get washed by the Gulf Stream. And that's why it's so very important. Well, one of the reasons why it's so very important, at least as far as maintaining the current climate, because if the Gulf Stream slows down or, God forbid, stops, then is a good chance that Ireland, England, and the Scandinavian nations, especially Norway and Sweden, will get quite a bit much cooler, which is counterintuitive since we're in a pattern of global warming. But that's what they think it might do. So this article yes, Jim.
That's that is most likely what will happen, because don't forget, as the water sinks vertically in the Jin Sea, it's sinking down, it literally is pulling the Gulf Stream along with it. So if the sinking slows or stops, it's not going to really pull the Gulf Stream with it. So yes, the Gulf Stream will slow, and it could conceivably stop. And of course, we all know that the whole conveyor belt is a big heat transfer mechanism for the planet. So now the temperature gradient will become sharper between high latitudes and low latitudes. And usually in the past, that's what's brought on the onset of ice ages. When the AMOC and the conveyor belt shuts down, so does the Gulf Stream. It gets a lot, as you just mentioned, it gets a lot colder up north. But now, my thinking is that even if the conveyor shut down, there's so much latent and sensible heat energy in the oceans down to 2,000 meters that I don't see an ice age happening. I see other things that are very bad happening, like productivity in the oceans going to zero, which would be a very bad thing. But we're kind of in uncharted territory here. I mean, from the past, you're looking at the work of Wally Broecker. Yeah, we've known what happened in the past when the AMOC slows down, the Gulf Stream slows down. We know that. Now, we're in new territory here with all this heat energy that's been introduced into the system.
Absolutely. There's so much heat coming into the system. People always say, well, we're actually heading into an ice age. People who don't really study this every single day. And I just look at them and I say, no, I really don't think so. There's too much heat coming into this system, even if AMOC slows down or shuts down. And then hence, of course, the Gulf Stream would shut down as well. There's too much heat coming into the system to have a day after tomorrow type of event. I don't know if you remember that movie, Jim. That was Hollywood's version of a disaster that, normally would spin out over, probably 1,000 years or so. Could you comment on the day after tomorrow?
Well, they took a little snippet of a scientific principle and kind of ran with it. They sort of almost kind of not quite got it something right. but
sort of.
But
it was very Hollywood.
Got to give them props for trying.
Yeah, they had good graphics, I must say. I loved all the graphics of, all this stuff happening and the water gushing in. That was great. But no, that's definitely Hollywood's version. In real life, the climate is much slower and not near as dramatic. And that's why most people find it too slow to find interesting. But a lot of us find it very, very interesting.
Well, the thing is, you always have to put these things in perspective. It may seem slow in the context, say, of a human lifespan, but when you extend it out over geologic time, it's an instant. So you always have to put things in the context. Yes. I mean, if it takes, 500 Absolutely. Years for sea levels to rise, say 20 meters, that's a geological instant.
And keep in mind, it took 1,000 or actually 1,000,000 years for the Permian mass extinction for those Siberian traps. They were going off over, I think, about 1,000,000 years before they had their big climax, at the end. So things take a long time in climate.
Yeah.
With this, I think we can move on to the New York Times article entitled, "In the Atlantic Ocean, Subtle Shifts Hint at Dramatic Dangers. The Warming Atmosphere is Causing an Arm of the Powerful Gulf Stream to Weaken. It's measurable," as we mentioned last week. Some scientists fear. Well, they always have to put those 3 words, which irritate the heck out of me, right? Very good graphics. If y'all get the New York Times online, this one is just amazing. It shows all the vortices and microcurrents, and it says the Gulf Stream has shaped climate and history on 4 continents. Beautiful graphics. Please take a look at this article in the show notes. Currents swing west.
Sorry for interrupting, but if you look at the colored portions off the coast of North America, you see those little like circular features there.
Yeah.
Those are examples of those mesoscale eddies I mentioned at the outset.
Yeah, this is just beautiful. The animation in this article is just beautiful. Current swing west from Africa, ultimately influencing weather patterns from Caracas to Miami to Europe. Warmer water sweeps past continents, slowly turning into cooler water farther north. And the Gulf Stream propels the heat of the Caribbean past Cape Hatteras, North Carolina, before bending toward the British Isles. So it kind of scoops up and then, makes a beeline to the British Isles. But this is kind of where it starts to reach some issues. But now, in the North Atlantic, there is the cold blob. Of course, the cold blob, which is absolutely huge and getting bigger all the time, is a result from the melting of the Greenland ice sheet. And of course, Greenland is melting about 8 times as much as it used to. The fear: melting Greenland ice will tip the delicate balance of hot and cold that defines not only the North Atlantic, but life far and wide. This is just a stunning article. Jim, would you like to kind of paraphrase and summarize what this article goes through?
Oh, wow. Well, basically,
or would you like me to? I certainly can.
I mean, the essence of it is, I'll give you my summation based on my experience as an oceanographer. All the freshwater melting that's being introduced into the North Atlantic, into the Jin Sea area, is slowing down chimney formation, what we call chimney formation. Kind of a fun thing, kind of a crazy term we came up with. But it's slowing down the formation of the deep water. So when you slow that down, as I said before, then the Gulf Stream slows down because it can't pull it along. Then the temperature gradient becomes more pronounced between high and low latitudes. The danger is that, yes, the conveyor belt is slowing down. This has ramifications for heat distribution, oceanic productivity. If I can take a step back, Wally Broecker, I know Wally Broecker's mentioned in his article. I was glad to see him mention the article because he really is the grandfather of climate science. A lot of the techniques in use today, or that's been advanced upon, are techniques that he developed and used. His Traces in the Sea, a book that came out in 1974, is still the go-to reference for looking at radionuclides in the ocean, isotopic tracing, how we identify water masses, and where the mixing between the different water masses occur, like North Atlantic intermediate water, North Atlantic deep water, Antarctic bottom water, all this. So he developed all these techniques. So I was glad to see him get a mention. But the work that he did with the AMOC and the conveyor belt, his models show that if you were to take a parcel of water that's in the Jin Sea, just as it starts to sink, and if you were to follow that, travel on a journey with that one little parcel of water, as it sinks, becomes North Atlantic deep water, flows into the South Atlantic, into Indian Ocean, into the Pacific Ocean, surfaces a little bit, sinks back down to intermediate water, and goes all the way back into the Atlantic, all the way, rejoins the Gulf Stream, and goes all the way back to the Jin Sea. That journey would take that parcel of water about 570 years to travel, to make that loop. So the other implication, and it goes a little further in my view, is something I've been trying to warn people about, is that you shut down the deep water flow. That not only is the conveyor belt a way to distribute heat, but it's also a way to distribute nutrients throughout the ocean for primary productivity. You start getting that stratification, as we have discussed before, you and Sandy have discussed before. You get that stratification, you can't get that mixing to bring in the nutrients. The primary productivity is going to go to zero. And one branch of the conveyor belt upwells in what we call the Antarctic divergence zone. And when it diverges, it's basically the water's upwelling. And so it's upwelling, it's bringing in nutrients. The phytos go to town with that stuff. And that's why the Southern Ocean is the most productive open ocean region on the planet. You shut down the conveyor belt, that entire food chain collapses with horrible implications.
That's scary. Well, that's talking about the death of the oceans then, Jim.
Yes.
The oceans die, we die. We are
Yes.
ocean. And, just to
this
give...
is why it's really very concerning for the scientists. It really is.
Yeah. The scale of this Gulf Stream and the AMOC, it's huge, right? It's 30 times more water than all the world's freshwater rivers combined. And in the North Atlantic, one arm of the Gulf Stream breaks towards Iceland, and this transports a vast amount of warmth northward. And it's, by one estimate, supplying Scandinavia with heat equivalent to 78,000 times its current energy use. That's stunning, right? That's really huge.
It is.
So without this current... Yes, please.
I've been looking at research papers, estimating the heat content in the oceans, and just trying to get a handle on things. One of the things people talk about, like, why is the sea ice melting so much earlier in the year when you have the polar night and there's no sunlight energy? Well, you just mentioned one branch of the Gulf Stream goes off towards the Jin Sea region. Well, part of that also goes through the Fram Strait, and you've got the heat in the Fram Strait. And just to give you an estimation, some of the numbers I've been working out, that one Sverdrup at that latitude contains about 5.93 times 10 to the 13 joules per second amount of heat. And the Fram Strait has a flow rate of 2 Sverdrup into the Arctic Ocean. So you multiply, so let's just say it's 1.2 times 10 to the 27 joules per second of heat that's being supplied into the... So you don't have to be a rocket scientist to figure out that that's going to keep the waters plenty warm.
Yeah. And scientists have detected that the ocean currents it's connected to may be slowing. So they've detected this by placing kind of a necklace of sensors across the Atlantic to understand the network of currents in the Gulf Stream, and hundreds of feet deep. So not on the surface, right? They're just detecting temperature and speed and all sorts of things. And of course, this is bad news. And the consequence could include faster sea level rise among parts of the eastern United States and parts of Europe. And it will also result in stronger hurricanes barreling into the southeastern United States, and also reduced rainfall across the Sahel, which is already a semi-arid swath of land running the whole width of Africa. That's the Sahara region. And this place, of course, is a geopolitical tinderbox. So, add drought to a geopolitical tinderbox, you're just going to get huge conflict. So they have been studying the Gulf Stream and kind of piecing it together from prehistoric climate records. And it has weakened in the past. This is not a one-time event. So it did weaken, and there were rapid changes that caused precipitation patterns to change in the North Atlantic. And of course, as we know, the Gulf Stream is just one tentacle of the much larger Atlantic meridional overturning circulation, or the AMOC current. And they have pieced the pass together from ice and sediment cores, and they have detected that in 13,000 years ago, the AMOC did shut down. Now that's curious timing. That was at the beginning of the end of the last ice age, right? That's when melt current 1A was in full swing. And of course, any of you who study meteors and things like that, that was also the time when a comet or a meteor, probably a comet, broke up across the Labrador region. That's where it impacted. And there are meteor comets impact craters in Greenland. They have detected them as the ice is melting. So this caused a huge melt event. And I think that that's probably what set off melt event 1A 13,000 years ago. Do you know about this comet strike across the north part of Canada? That was when the ice was about 2 miles thick.
I have heard about it, yes.
Yeah, it's worth a look.
As you just stated, there has been, and it's documented, we have the data for it. You can look at the Driest, for example, of
right.
when AMOC slowed down or stopped totally, and the planet got cooler, or it went into an ice age. So we have the data for that. And again, Wally Broecker is the guy who basically was finding the stuff out at first, using, as you just mentioned, the cores from sediments and ice, looking at isotopic fractionation. We can reconstruct,
yes,
whether it's just the Del 8 or Del O18, the Del C13, especially those two common ones. We can reconstruct past climatic situation. We can even tell you when the conveyor was on or off. We can discern all that information from looking at the isotopes. I did a video of isotopic fractionation where I explain all of that.
Oh, fascinating. And, the AMOC has tipping points. And of course, these are thresholds in the Earth's climate system. And the thing about tipping points, once they're crossed, they have a rapid cascading effect far beyond the corner of the globe where they occur. It's a switch, and one that can be thrown quickly. So people feel that we're getting close to this tipping point switch. This brings us to the cold blob. That could be the tipping point switch. As we know, Greenland is melting and melting more and more all the time. And that large patch of the North Atlantic has become much more cold in recent years. Deep beneath the surface, scientists are searching for changes in the currents. And there's some beautiful graphics in this article. Some fear that meltwater from Greenland is already inhibiting the northward flow of the Gulf Stream. Atlantic currents are a complex engine powered by wind, salinity, and heat. Potential disruptions in the vast cycle of water sinking as it cools cut to the heart of the scientific unease. So this cold blob may signal that the northern arm of the Gulf Stream no longer arrives with the same strength to the North Atlantic. That a warming atmosphere has paradoxically cooled one part of the world, the cold blob. So this is new science, and not everyone agrees that the AMOC is actually slowing. But both scientific modeling of climate change and the prehistoric record, a North Atlantic cooling, presages a shutdown of the current. One of the hallmarks of a shutdown is this cold blob. The cold blob is a big deal.
It is. And by the way,
you want to...
there has already been documented slowdown in the deep water formation. There's already been documented slowdown in the flow of the Gulf Stream. We have the data for this now in the over the last couple of decades. Right now, the Gulf Stream, I think, is at the weakest in about 1,600 years or something like that. I could be slightly off of my numbers, but the Gulf Stream is at a weak point in its history right now. So yes, that cold blob, which is what we call a freshwater lens that's been introduced into the North Atlantic, because you're now throwing so much fresh water in there, you're reducing the salinity and the density of the water there. So now it's no longer as dense, it's not going to sink. And that's kind of the crux of that whole reason as to why it's not sinking, why the sinking is slowing down, hence the Gulf Stream is slowing down. So yes, we're warming the planet, but then we're going to create this cooler region of the planet because there's a thing called Greenland in the way with lots of ice.
Yeah. And at the beginning of the last ice age, when this big melt started in earnest, melt pulse 1A, temperatures fell by around 10 degrees Celsius or 18 degrees Fahrenheit in parts of Greenland, and Arctic-like conditions returned to parts of Europe. And I believe that's what's called the Younger Driest, is it not, Jim?
Yes.
This is a cold snap that lasted about 1,300 years. And it reversed even more abruptly than it began. So it was just this quick little 1,300 year, freeze. And then it turned around. And that's the fascinating thing about climate, how quickly it can change sometimes.
That's an interesting point because because Wally Broecker actually demonstrated in his models that the thinking was, it's going to take hundreds of years for the switch over. He was able to demonstrate that the conveyor belt can start up, stop, whatever, within a matter of decades, and to use his own quote, like flipping a light switch.
Yes. And he also said the climate system is an angry beast and we are poking it with sticks. So I think that we can probably move on to the next article, just kind of keeping our eye on the time. Do you agree?
The video.
Oh, the video. The video. It's time for the video.
Get the popcorn.
It's time for the video.
We're trying to go back in time 250 million years and piece together what caused this massive catastrophic extinction.
Dr. Uwe Brand is a geochemist from Brock University in Ontario, Canada. He's been investigating an event called the Great Dying, when 90% of all ocean life and 70% on land just disappeared. Exactly how it happened has baffled scientists for decades.
People over the years have speculated on causes. What caused this disappearance of life? And everything from meteorites, asteroids, extraterrestrial impacts, to things happening here on Earth.
Now Brand and other scientists may have the answer. In 2 papers published recently, they analyzed the chemical makeup of ancient rocks in Italy and China. They discovered a rare substance called coronine, dating back even before the dinosaurs, 250 million years ago, which can only be formed when fossil fuels burn at extremely high temperatures. The culprit turned out to be a million years worth of volcanic eruptions in Siberia. Brand says that most of this was a gradual process, but towards the end, an escalation of volcanic activity and a spike in greenhouse gases was the nail in the coffin.
This was not a volcanism in the traditional sense where you simply have volcanoes and they spew out material. They were more like fissures, cracks in the crust, where the lava flowed either on top of the land or it was squeezed in between sedimentary rocks.
It all happened at the end of the Permian geological period and created lava beds that were massive.
The size is equivalent to at least half of the United States. and to a thickness of several kilometers.
As the lava squeezed through the cracks and crevices, it seared large underground deposits of coal, oil, and gas, releasing extraordinary amounts of heat-trapping greenhouse gases like carbon dioxide and methane. In fact, concentrations were much higher than today. Globally, the atmosphere warmed to levels 18 degrees Fahrenheit higher than they are right now, forcing animals and plants to adapt, move, or die. At the same time, carbon dioxide combined with water to produce sulfuric acid, and that acidified the oceans. Coral disintegrated, and the shells of ocean creatures dissolved. Now, on land, the hotter climate shifted vegetation and ignited fires. That exposed more rocks, and erosion went into overdrive. As a result, an overabundance of nutrients flowed into the ocean, causing, at first, an explosion of life. Then, the inevitable death and decomposition, eating up most of the life-giving oxygen in the ocean and suffocating life. Existence was getting hit from all angles.
These are not individual and separate causes, but they all acted together. They acted in concert. And that's why I call it the perfect storm.
As catastrophic as the Great Dying was, scientists are concerned the Earth could now be headed for another disaster. Right now, the planet is warming abruptly to levels not seen in over 100,000 years. Oceans are acidifying, and oxygen dead zones are multiplying. And astonishingly, the rate of release of heat-trapping greenhouse gases right now is much more radical than it was back then.
Our emission is 10 to 20 times higher than what happened during the end Permian mass extinction, which was the largest and biggest mass extinction.
But Brand also says we still have time to turn this around by moving away from the burning of fossil fuels. He says to save ourselves, we have to learn from events like the Great Dying.
You know what they say, learn from history, because if you don't, you're going to repeat it. The way I see it, yes, it's going to happen if we don't stop it.
Jeff Baradelli, CBS News.
Wow, that was a really fascinating video. And they actually read the entire article, which you can find in the show notes. And what is just fascinating to me, Jim, is how quickly we're moving along here, because we are going into this sixth great extinction 10 to 20 times faster than was done in the Permian mass extinction. And to me, that's absolutely stunning.
Well, there's a couple. First of all, there's a little error in the video there. The reporter said when you mix carbon dioxide and water, you get sulfuric acid. That's carbonic acid. If you have sulfates or sulfites, that combined with water is what will give you sulfuric acid. So I just wanted to clarify that little point there. The scientist is absolutely spot on. If you want to know what's happening now or what's likely to happen in the future, study the past. I've been saying that on my videos constantly, because that's what we do. Like what we discussed just now about when we look at the isotopes, we can reconstruct the past climate and past situation. Well, we can apply that to current situations. So that's correct. The thing here is that, he's talking about, temperatures were basically 10°C warmer. 18F is 10°C. Keep in mind, about 53 million years ago, we had the PETM, the Paleocene Eocene Thermal Maximum, where temperatures were 18°C above pre-industrial levels. So even the heating of the planet during the Permian was about halfway towards the heating during the PETM. Well, we are on path to going halfway to the PETM. Some models could say by 2100, some are saying 2050 now. And because there's another thing going on, I just put out a video talking about Arctic trees and stuff like that. As the temperatures get higher and higher, trees and plants will be killed off because trees, like any other organism, have preferred temperature ranges. So trees will lose a lot of their moisture through transpiration, and then instead of drawing down the CO2 to do photosynthesis, they start respiring more, which means they draw down oxygen instead, put out more CO2, and then combine that with what's going on with the ocean, warming and all the latent heat energy. Eventually, the oceans will not be able to absorb any more CO2, aside from the fact, well, CO2 is acidifying the hell out of the ocean. So then the oceans are going to start outgassing back the CO2. And so now you've got the permafrost on. You got all these mechanisms kicked in. Let's throw in, just for yayas, a few more positive feedback loops. And I can understand how some people are saying we're going to hit 10, 20 C increase by 2050.
Yeah, absolutely. I mean, when you connect all the dots and you see the trend lines, carbon dioxide in the atmosphere is increasing at a pace 100 times faster than it should. Our planet is warming 10 times faster than it has in 65 million years. And our oceans are acidifying 100 times faster. And that's just now. What's it going to be like in 10 years, right? Dead zones, oxygen dead zones. That's really scary. That's pretty much all along the perimeter of the continental margins, as well as huge swaths into the deep ocean. That means that, fish can't live there. And so these, it's just really scary. It's really scary.
That's correct. And if you consider that, if you get the stratification to really firmly set up, where you really have a massive barrier between warm waters on the top and everything below that, you have no productivity. So a lot of your oceanic productivity is going to go down to zero, near zero, if not zero. You might have some onshore Ekman transport in some, isolated spots, but overall, we know that the phytoplankton provide 55 to 80% of atmospheric oxygen. So if you lose, say, 90% of the phytoplankton, well, the Earth's atmospheric oxygen content is going to drop from 20% to under 10%. That means air-breathing organisms are not going to have enough oxygen.
I'm not
being fear-mongering. This is scientific principles.
Would you guys like to take a question from the audience?
Yeah.
I'll put it up. It is Lisa S. If there is enough melt, could that have an impact on the plates moving?
Interesting question. And I would say
isostatic rebound. In which, for example, we know that when the great ice sheets receded from North America, you had what's called isostatic rebound, where the weight was removed from the continents and they started rising higher, in elevation. Will that impact the plates? I don't know, but my guess, maybe not as much as one would think, because the plates are pretty much driven by what's going on at the margins, at the ridge zones, with the magma pushing up, coming up and pushing the plates aside. And then you have the subduction zone where the other end dives underneath into the mantle for the rock to melt up.
I would say that the isostatic rebound that would result could have an effect in terms of lots more earthquakes, lots more volcanic activity, and also it would disturb the methane stores that are already there. And given the heat and the isostatic rebound and the additional earthquakes, that could release huge methane stores. So yes, I would say that could have a huge effect. My opinion.
Well, earthquakes, yes, but the question was about plates themselves. So I took it to mean that, affecting how the major plates on the Earth's surface themselves move around. That was my interpretation of the question.
And how
I saw another question there that you put up, Sandy, didn't you?
Yes, it's from Jim McHenry, and it says, H2S with slowing of Gulf and algae bloom?
Hydrogen sulfide.
Hydrogen sulfide.
Yeah. Jim, do you want to take that
Um,
one about the hydrogen sulfide?
I'm not sure I even understand the question. Could you clarify,
Well,
please?
I think that what they're talking about is, could you have hydrogen sulfide seas, kind of like a Canfield Ocean or something like that? And could that result from the slowing down of the currents? That's my interpretation of what the question is.
I really don't know enough about that to say anything meaningful. I mean, you have the H2S from the hydrothermal vents, out in the, for example, out in the Pacific, Juan de Fuca. But that,
And
I don't know.
I would agree with this next one from Jim McHenry. Could you leave that up, Sandy, so we can see it, please?
Yes, I'm looking for it. Okay, here we
He
go.
said something about the weight distribution, and that's huge. We've already experienced a huge weight shift since the end of the last ice age. The oceans went up 430 feet, all told, since the end of last ice age till now. Mostly in melt pulse 1A, 1B, 14 to 10,000 years ago. But think about how much weight that melting ice is, and the shift that would have on the plates, right? And the resultant isostatic rebound. That's going to shift the distribution of weight. And in my mind, that's going to result in earthquakes and volcanic activity. All of that.
I'm not arguing that, but the question about the mechanisms itself of plate tectonic movement is a different mechanism. I'm not arguing, I'm not disputing there's going to be an increase in earthquakes and volcanic activity. I'm basically referring back to the actual physical mechanics of how the major plates on the surface of the planet move about. That's a different mechanism that comes from deeper under the crust. Will distribution, when you have ice that's on land, you put it in the ocean, yes, you're going to have weight shifts. Yes, that could cause earthquakes. But is that going to be a major contributor to moving the plates around? I think the jury's out on that.
Let's move to Wendy Delis.
So this next question from Wendy. Some people believe that in a technical sense, a mega drought has already begun in parts of the USA. A mega drought that for now, the question went away, that for now is softened by soon to run out irrigation water from the ground. Oh, absolutely. The Ogallala reservoir under the United States. And of course, when we're pumping out all of that reservoir water from basically left over from the last ice age, the land is also depressing. So yeah, I would agree that we are probably at the beginning of a mega drought. And Jim, do you have some opinion about this one as well?
Well, I totally agree. I think the West is in a mega drought as it is. The other thing to keep in mind is that as you keep pumping out the aquifers, what's going to happen is in a lot of cases, brine water replaces the fresh water, and that starts, the crops are not adapted for that, so you're going to start killing off the crops.
That's right. And as the temperatures raise, the interior of the continents dry out, and it's the interior of the continents that are going to experience the highest levels of drought. So some places are going to get more water, and some places are going to get less water. And the places that'll probably get less water are the interior of the continents, aka mega drought.
No, I totally agree. In fact, when you look at when it was Pangea and Gondwana land and Laurasia and so on, the middle of those continents, we've been able to reconstruct it to be very arid regions because of the distance from receiving any meaningful precipitation from the ocean. Any clouds that form long dry out before they reach the middle of such vast places. So yes, I would totally agree with you on that one.
Oh. Sandy, could you put up Wendy's question about hydrogen sulfide seas again? Wendy
I
says
sure will.
H2S, hydrogen sulfide, results from especially low oxygen levels in the ocean, right? That's happening. Oop, it went away again. You got to leave it up there.
It's on a timer.
Oh, H2S, which can result from bacterial breakdown from some types of protein, gets oxidized into sulfuric acid. So, yeah, I mean, in a low oxygen environment, I think that's called a Canfield ocean, you know, when H2S takes over, hydrogen sulfide becomes a predominant feature. And I think we're heading that way. What do you think, Jim?
Well,
You're
if we
the
have the
oceanographer.
stratification, you certainly go, and we see this in lakes, by the way, where you have anoxic, hypoxic regions, typically near the bottom of the lakes. So if we get this massive ocean stratification setting up, which we're on the way to doing so, then I can very well see that happening. We're going to create hypoxic, anoxic depths and zones in the ocean. So yeah, it is very possible, very conceivable.
All in all, Jim, I would say it's a pretty freaking grim picture. Non-happy. Maybe some would call it a doomist outview. So millions of years of the sun's energy pumped into atmosphere couldn't end well, but profits and privilege are blinding. Isn't that the truth? Capitalism equals death. You know, it's a selfish, very high consumption way of living, and it's put us into the situation that we find ourselves in today, unfortunately, you know.
And as we come out of this virus situation, the emission levels are returning right to where they were pre-COVID. It's like human, and there's a race now. Oh, the Arctic is going to have a BOE. Let's race there and get all the resources from there. Not learning a damn lesson.
No, I don't think we shall. I don't think we're capable of learning that lesson. Certainly not en masse. I haven't seen any indication that humanity is going to wake up and smell the coffee on this one.
Smell the coffee in the coffee house. Yeah, no, it's not good. And you know what's the definition of insanity? You know, doing the same thing over and over and keep expecting a different result.
Yeah.
Do we have any more questions out there in the audience? We have Louise is here, Louise Clifford.
Oh, hi, Louise.
Hi, Louise. Drying up of underground water is already happening in my area, in Queensland, Australia. Our bores are going salty. Our dams are also drying up. We have not had much rain. It is very dire.
It's so sad. I've been in correspondence with Louise a bit over the last many months, and my heart goes out to you, Louise. Bores, for those of you that don't know, in Australia, they're kind of like wells, and you get your water from them, and their bores are becoming salinated or drying out altogether. You know, Australia is in a very tough situation. So, Louise, our heart always goes out to you and all your mates in Australia.
Yeah, and that's an example of what we just discussed. You know, that as you suck dry the aquifers, it's going to be replaced by brine. You know, there's an example right there.
Yeah, and Hoople's cat says, "Doomist or realist?" I'm a realist. Hoople's cat, I agree with you. I'm a realist as well.
We're calling it as it is. You know, you cannot, you know, you can't deny the physics.
No, can't deny the physics, that's for sure. Can't change the law of physics. Oh, if somebody wants to say hello. Hello.
Pretty kitty.
Hello,
Yeah.
kitty. I have 6.
Blends in with your coat.
That's right. We're color matched tonight. Cognitive dissonance makes us all comfortably numb. Pink Floyd. Oh, beautiful. I love Raza Eco Warrior so much.
And yesterday was David Gilmour's 75th birthday.
I should have had something in the queue. Well, how do you
And
feel,
then-
guys?
And then Trish Kaiser says, is there going to be a Blue Ocean event this year, or does it even matter? Well, the trend is the trend, and that's where we're going. Whether it's this year, whether it's in several years from now, we're going that direction. So just hang on to your hats. It's going to be a bumpy ride.
Jim has a question here.
My question is, would it be possible for the
to-
Gulf Stream to be redirected? What was that? To be redirected into Baffin Bay as a result of the blob off Greenland? Oh, that's a Jim question for sure.
Short answer, no. Just when you look at the physics of, when you look at vorticity considerations, geostrophic heights, and other mechanisms, wind stress, for example, and Ekman transport, I do not see that being likely. I can't think of a mechanism off the top of my head where that is a possibility.
Nope. Well, Sandy, that brings us to pretty much top of the hour here. Would you like to call it?
I think we have one more question. And that's
One more?
Nostradamus, our best buddy,
Oh.
David. Has Jim seen any reports about disruption to vitamin D production in the oceans?
Vitamin
Okay,
D.
first of all,
Wild.
I'm more of a physicist than a chemist. I mean, I understand some of the basic chemistry, but
Okay.
specific topics like that it doesn't come across my radar very often, if at all. So I can't really comment on that. I'm following more the physics, the heat distribution. My research was heat budgets. That was my research. Heat budgets and sea ice. So, physics is a lot easier than chemistry. I can handle the physics. I can't quite handle the chemistry. I'm not that smart. I don't know if I'm smart at all, but I can handle the physics a lot easier.
Yeah, but Torsten says that Baffin already gets part of the AMOC. Ow, ouch. Anyway, ow, that hurt.
I have not seen evidence of that. So I'm going to need to look at that. I have not seen it in the papers in like Journal of Geophysical Research, anything like that.
Jim,
There's
you
a
have to
question
answer
from Patrick McNulty, and he wants to know, Jim, have you viewed the ocean mechanical thermal, could you try again, thermal energy conversion video?
Not yet.
On Just Have a Think?
Not yet. But, well, I'll reserve judgment. No, I won't say anything. But I haven't seen it, so we've had discussions before. Written chats. I've expressed my questions about that procedure, so I'll have to see the video to make a further assessment.
Well, all in all, I think this has been a great show tonight. Great questions too. Thanks for all your participation, guys. We really appreciate spurring us on. And this place should be called Ocean, not Earth. I mean, we're 70% ocean on this planet, and the IPCC almost didn't mention ocean in one of their reports, which just shocks me. Yet again, our perspective is so self-centered. But, here we are, guys. We're just taking a look at it, and, here we are. Jim, you got anything else?
Well, I've been long saying the planet should be called Oceanus. It's actually a scientific publication with that name. IPCC, not reporting in the ocean, not reporting on methane. Are we really surprised?
Not reporting on feedbacks, not reporting on climate sensitivity, not reporting on ecosystem connectedness. Can we say more? Guys,
Right.
that's why you like to watch this show, because we try and bring it all together under one umbrella so everybody can understand it.
And folks are interested to learn a little more about the physics behind oceanic gyres, Western intensification. I did a video called Rotating Systems. Don't worry, there's no math in it. But if you're interested, you can go check it out. I describe rotating surface in the atmosphere and in the oceans. You know what gyres are: Ekman transport, Ekman spiral, convergence, divergence, upwelling, downwelling, etc., etc. If you're interested.
All right. Well, thank you guys. It's been a great show.
Thank you, Jim. Thank you, Sandy.
Thank you,
Appreciate
Jen.
the time.
Thanks everyone for joining.
Peace out, everyone.
Peace out. Have a great week. See you next week.